end of this video, you will be able to know how to draw a simple pad foundation footing like this one for a chain link fence, as well as how to calculate the volume of concrete required for a foundation pad, as well as how much of that volume is cement, sand, and stone based on the mix ratio. And finally, you'll understand how to determine fill material volume when you are given a compaction percentage. Now, all of these are basic mathematical skills. The only difficulty is your interpretation of the questions.
So, in this portion of the video, we're going to be producing the sectional end view of the boundary fence. As you can see, they say that the boundary fence is 2.4 meters high. Alright, we don't need to concern ourselves about the length of it when we're dealing with the sectional view. We need to concern ourselves though with the 250 millimeters above ground level for the block wall, as well as the depth of the footing, which is 900 millimeters below level. We also should concern ourselves with the thickness of or the dimension for the pad portion. So we're going to be producing this drawing here to our right side. Alright, so let's start things off by drawing an horizontal line, and this horizontal line will represent a random horizontal line. That line will represent our ground level. Alright, so let me add a text to denote that. So I'm going to add GL there. See what's going on here. Let me change my text size from 50 down to about 1. Alright, from here, what I'll do, I'll just scale down my text, because what is happening here, I've set up my drawing space to be using the unit meters instead of millimeters. Alright, there we go. Alright, so that's our ground level right there. Now, what we're going to be doing is that we're going to be offsetting this line here down the distance that they say that the foundation is, or the pad footing is. Now, they say that it is 900 millimeters. So if we convert that to meters, we're going to be equal to 0.900, and then we can offset that down. All right, so that's how far the foundation is. Now I'm going to be offsetting the height of the fence, because it says the chain link boundary fence that is 2.4 meters high and on top of a 150 meter thick block wall, that is projected. Okay, alright, so we're going to start things off by doing the foundation pad first. So let's draw a rectangle that is equal to 450 millimeter by 300 millimeter. So I'm going to go REC, enter, click, enter that 450 first, which is going to be 0.450. Alright, then tab key, and then 0.300. Alright, that will give me my rectangle there, and I can grab my rectangle and place it where it needs to be. Let me turn on O snap here, so I can grab onto a specific point on this. Alright, let's move it over a bit more. Alright, now that we have that in place, it's time for us to focus on the remaining portion. Alright, so it says that there's going to be a what? There is thick block wall that projects 250 millimeters above ground. So this is the ground level here. So what I'm going to do is that I'm going to offset that 250 millimeters up. So I'm going to go 0.250 when we convert to meters. So we know that the block wall the chain link fence starts above here. Alright, now, and we also know that the wall, concrete block wall, goes all the way up to this level here. So I've just drawn a line in the exact middle or center of my pad here, footing, and I'm going to offset on. Let's offset again, offset 0.075. Now we're there. Alright, so one on that side and one on the other side. Alright, and that there is our block wall. We'll keep this middle line here that will represent our steel in the middle, and we'll continue from there. So this is the ground level here. Let me scale down my text a bit lower. 0.5. Alright, so this is our ground level. That is our ground level. Alright, so that's our ground level, and this will be our steel in the middle. So let me just add it to the relevant layer, steel, and then this would be our block wall, and go a conch wall. Where would I have that? AC. You know what? Let me just put it here. Alright, for now. Oh, here it is. A wall conch. Alright, so we have it there. Alright, now once you have that in place, the next thing we're going to be doing is that we're going to be offsetting this line here up by the 2.4 meters. So O, enter, 2.4 meters. So let's offset that up. Alright, and we know that chain link fence is going to be from the center here all the way up. Now depending on how thick the chain link fence is, so to represent that, what you're going to be doing is that you're going to be offsetting, because I think the pipes for the chain link fence that is going to be bracing between is going to be equal to about 2 inches. So what I'll do, I'll offset, so 1 inch is 25 millimeters. Alright, so if I go O, enter, 0.025, enter, and I offset that on either side, that should give me the thickness of the piping or the supports for the chain link fence. There is also going to be a circular portion up top. Alright, so I'm gonna offset a line down by that 0.025 as well. Alright, and let me just trim away those extra lines there. Alright, and I'm going to use that to create a circle somewhere along here like this. Alright, so that will be that portion there, and I can get rid of this line, and I can also trim away these top lines as well. Alright, so and then from there I can remove this line. So this will be the pipe on top, and right exactly in the center I'm going to draw a little line that will represent my chain link wires in the middle. Alright, so it's going to come right down in the middle like that. Alright, so just like that, you have that portion there done and dusted. Let me clean up my drawing a bit by trimming away these excess line here. Okay, and then now we just need to sort out the reinforcement inside of this portion here. Alright, so what we're going to do, I'm going to offset. Let me first expose this here first. X, EX. Alright, let me get rid of this line here. Alright, so that should separate. I'm going to offset 0.050 for the cover on the bottom like that, and then now I can extend this line now to touch this line. So I'm going to go EX, enter, let's send that down to this here, and it will stop. So let me offset 0.50 again to this side here like that, and to this side here like that. I'm also going to offset this one here up as well, and I'm going to be filleting the remainder. Alright, so I'm going to fillet this to this. Alright, and I'm also going to be filleting this to this, and I'll use this line to trim away this portion here and this portion here. Once I have that out of the way, I can remove this line here. Nothing more, making things simple. Alright, grab onto these, and then you simply change the layer, because that is going to affect my drawing. Alright, now once that is done, the next step is to do some matching patterns. So you could probably, I don't know, let's just keep things simple and just draw a line somewhere along, let's see, maybe along here. Alright, and let's just draw another random line somewhere along here. Alright, and we're going to be hatching the area. We're going to be hatching it using a hatch pattern called Earth. So we click on the drop down menu, find the one that says Earth. Alright, it's going to look like a bunch of crosses. Alright, so let's look. So we're at D now. Alright, we're at there now. Alright, so we have passed it. Alright, so here's Earth, and we're going to place a hatch pattern here as well. And for the scale, maybe we can go 0.01, enter. Alright, close that one out, and then we'll apply another one inside here, so another hatch pattern in here. Alright, you can also rotate your hatch pattern if you like. Alright, to make things a bit better. Alright, now once that is done, you can get rid of these lines that you had drawn. Alright, get rid of that. Alright, maybe you can match some properties to get it to turn the way this is over here. Alright, just like that. So this would be it. Remove this ground level line that runs across the top here. Alright, now the only other things that you can do here, you can also hatch inside the block wall using, I'm going to show you the one that we're going to be using, one of these here. Alright, and you simply hatch. Let me double check on use this one, hatch that one and that one there, and we can change the scale. Let's try 1, no, 0.05, enter. Alright, let's see if what's happening here. 0.005, enter. Alright, cool. So let's now change that to 1. Alright, let's go 2. Alright, that is good enough. Alright, so that will be our chain link fence section. The only thing that will be missing from this here is that you could hatch down here with the concrete hatch pattern, and then you'll add your dimensions. The dimensions that you would be adding would be the dimensions that were given to you. Alright, so let's hatch that portion there with the AR conch. Let's go AR conch, and you'll hatch inside here. Alright, just like that. And then now we can add our dimensions. So we'll add our dimensions. So let's go to annotation, click on linear, and grab onto here and add a dimension. Alright, now if your dimension is way too big, then it means that you need to go to dimension style, and you're going to reduce your dimension size. So you go modify, where it says text, you'll reduce all of this. Alright, so you could change this to probably 1 or so, and then you go through where it says arrow and all of that, and you change those as well. But to make things simple here, what I'm going to be doing is that I'm going to use the one that says standard. I'm going to set it as current. Alright, and then I'm going to modify that one there. Modify. Alright, change these to you could go architectural, tick or oblique, it's up to you. Alright, where it says text, we'll just keep everything as is for now. Alright, and then now we simply click on set current. Let's get rid of this one that we have here, and then let's add our dimension. So let's go to linear and add the dimensions that were given to us. Alright, so let's go DIMSTY and sort out our dimension a bit more. So let's go modify. Alright, so for the text, it's currently at 180. Let's set it at 100 or 0.100. For arrow size, they're going to use the same thing. For the arrow symbol and the arrow size, let's change it to 100 as well. Alright, all of that should be good. Let's just leave that for now. Set current, and let's close things out. Alright, let's make things even smaller. Maybe we can go 90 or 75, 0.75. Let's go there. Alright, so let's go and let's add it. So that will be 0, 75. And then text 75, 0, set current and close. Alright. Then now you can also dimension the other portions, such as the height that was given to you. Alright. You can also dimension the height from the floor to the base, or the ground level to the base, 900. And you capture also here to here. Alright. Now you can always modify your dimension text to make things a bit neater as well, after you've sorted out everything and you know that you have time remaining. Alright, so here we go. Alright, so there you go, and that is the sectional view of your fence. Alright, so all you need to do now is to just go through, make things a bit neater and all that fancy stuff. Alright, next we move on to the other sections.
Okay, so now that you have produced your sectional end view of the boundary fence that we have here, with the pad footing, the stem wall, the ground level, showing the ground hatching, labeling the ground level here, adding in our dimension, the reinforcement, and the chain link fence with its relevant support, it is now time for us to move on to the second section of this portion of the exam. Alright, so it has asked us to now calculate the volume of the following building material: the cement required for the foundation footing, the sand needed for the foundation, and the stone needed for the foundation. Now what is it talking about? It is referring to the pad portion here. Alright, and remember they had given us the dimensions, which is, they said that it is the boundary fence is 2.4 meters high, and they said that it is 40 meters long, so the length of the pad is going to be 40. Alright, additionally, it is constructed on top of a 150 millimeter thick, alright, a 150 millimeter thick block wall that is projected 250 millimeters above ground level. 250 millimeters above ground level. The wall is sitting on, and this is the foundation that we're going to be calculating. So this is the dimensions that we need: 450, alright, by 300 reinforced concrete. Okay, so we're going to be multiplying those numbers now. So we're going to be taking the 450, the 300. So we're going to be taking the 450 and the 300, as well as the 40 meters right there. Alright, so let's do those calculations now. So let me just pull these down to where we're going to be doing our calculations. So we have the 450, and we have the rest. Alright, so those are the dimensions that we have. Now we'll have to convert our millimeters to meters. Alright, so to convert our 450 to meters, similar to what we did before, this will be 0.450. This 300 millimeter here will be 0.300. Alright, and we'll multiply this across. What will we get? Let's put it in our calculator. So we have 40 meters times 0.450 meters times 0.300 meters. That gives us a volume of 5.4 cubic meters. So that gives us a value of 5.4 cubic meters. Let's add the cubic. So 3. How do I do that again? Like this. Alright, so this is now This is now the volume that we need. Alright, so the volume of concrete is going to be this. Now we now need to determine how much of this is cement, how much of this volume is sand, and how much of this value is stones. Now this is basically a ratio question, so let's tackle that now. Alright, let's first determine the ratio. The ratio is 1 to 2 to 4. Let's copy this down. So the ratio is 1 to 2 to 4. So we need to find the sum total of all the parts together. So we need to summarize all these values. So we need to add 1 plus 2 plus 4, and that will be equal to, so 4 plus 2 is 6, and 1, that's 7. So there are 7 parts in this volume here. We now need to determine the amount of that value, which is what? Cement. Alright, now cement is the one part. Alright, this is cement, this is sand, and this here is the gravel. Alright, so what we're going to do now is that we're going to take the total volume, that is this here, or total volume, alright, which is 5.4. Alright, let me write that here, 5.4, and we're going to be dividing that value by 7, and that should give us 5.4. So let's do that one there, 5.4 divided by 7, that is equal to 0. And we're going to just work with the first 3 digits. Alright, so that is equal to 0.771 cubic meters. That's cubic meters. Alright, so that's the value there. So we now know that one part, so 1 is equal to this value that is here. One is equal to 0.771 cubic meter. So it therefore means that sand, and I'm going to, let me just put it probably to the side here. So sand, not do that, sand is equal to 0.7. Now we now need to determine how much of this value is, oh sorry, that's not sand, this should be cement, sorry, cement. So we have our cement value right here, so it's time for us to determine our sand value. So sand will be equal to, the second value, which is 2 multiplied by this value that is here, because this is equal to what? 1 part. Alright, alright, so if we multiply that value by 2, what will we get? Times 2, that will give us 1.542. and that is cubic meters. Once we have that out of the way, we now need to determine the stone. Now the stone will be equal to, because the stone part is, as I said, 1, 2, and 4. So the fourth, the volume of stone will be equal to 4 parts. So it will be 4 multiplied by this value here. And that will be equal to 4 times that value. Let's do that one. This will be equal to 0.771 times 4, and that will be equal to 3.8 parts, and that is in cubic meters as well. Alright, so this here will determine, or this here gives us the total amount of aggregates that will be needed for the foundation. So it requires 0.771 cubic meters of cement, 1.242 cubic meters of sand, and 3.084 cubic meters of stone. And that is the amount of material that will be required to complete our foundation pad there. Now again, remember, whenever you're determining the quantities of material and you're given the ratio, because this might not always be the case where you have 1 to 2 to 3 to 4. It could be, this could be 3, or this could be 1. It doesn't really matter. The first thing you should always do is to add up or total the number of parts. Alright, whatever you get, that is what is going to be determining the total parts of the volume. Alright, once you have determined the total parts of the volume, you need to find out how much is one part. Once you have determined the one part, by simply dividing the sum of the ratio by the total volume, you'll get the value for one part. That one part, you'll use it to determine the volume of each individual aggregates or component that will make up the concrete. For example, the cement, sand, and stone. Alright, please note that this will be posted down below, so you can always download this file here and have a more detailed inspection of how the calculation was done. For part B of this question, it says that a floor area with an internal measurement of 20 meters by 8 meters is to be filled with compact marl. The height of the structure is 300 millimeter, including a concrete floor slab that is 150 millimeters thick. The natural ground level should first be stripped to a depth of 150 millimeters. You are required to calculate the amount of marl needed for the floor and allow for a 30% compaction. Now, it means that we need to determine the volume of the amount of marl that is required. But there are some key things to note. That they said that of that 300 millimeter of the floor level to the ground, 150 millimeter out of that is going to be a concrete slab. So it means that we need to deduct that from the 300. That should give us 150 millimeters remaining. So the thickness of the marl is going to be 150 millimeters. Alright, so we're going to calculate that. As you can see down here, we took the values that we got, the 20 meters, the 8 meters, and the 150 millimeters, and we converted that to meters. When we multiply that across, we got a volume of 24 meters cube, or 24 cubic meters. We then determine the 30% of this value here. 30% of that 24 cubic meter is actually 7.2 cubic meters. Now we add the percentage to the initial value, to get the total volume of marl that will be needed to purchase to fill that space, all right, while accounting for the compaction volume, because when it is compacted, the marl is going to shrink, all right. So it means that if we do not account for this 31%, it means that the floor level or the marl level is not going to be at that 150 millimeter where it should be. It's going to be lower than that, and we need it to be at 150 millimeters thick. So it therefore means that we need to get an additional 7.2 cubic meters of marl to add to that area to get it to that level. And this is how we basically calculate fill material when given a compaction rate. And whether this is 20%, 30%, or 40%, depending on the compaction material, the process will remain the same.